Sir, is the program visible on the screen?
नो,
एक सेकंड, नहीं अभी तो नहीं दिख रहा है।
Okay. ज्यादा जूम हो गया था शायद, अभी ठीक है?
yeah, this looks
नहीं
fine.
अभी भी नहीं।
Please.
सर छोटा स्क्रीन में दिख तो रहा है शायद।
दिख रहा है. You can enlarge it little bit.
अभी ठीक है इतना साइज? डॉक्टर चंद्रभान दोहारे जी, आप कुछ कहना चाहते हैं? यू वांट टू से समथिंग? यू हैव रेज्ड योर हैंड।
You can ignore those things.
इंद्र,
यस सर।
अजय मैंने वो एक उसका पीपीटी फर्स्ट पेज का बना दिया है, तो देखो अगर वो शेयर हो जाए तो पीपीटी शेयर कर दो।
आपने मुझे सेंड किया है या आप शेयर कर रहे हैं? मैं स्टॉप शेयरिंग
नहीं
कर सकती
नहीं, मेल तुम्हें किया है।
हूँ? ओके। Is this okay? This one?
हाँ, दिस इज फाइन।
Okay. Sir, your voice is not coming properly. We cannot
किसका?
hear you properly.
हेलो,
अमित सर, हाँ,
हाँ, यस,
बीच में से आ रहा है सर, पीछे से.
Ugramon, we will request everybody to switch off the videos and their microphones. So only when you have to speak, kindly switch on that, and you can switch off the video so that the bandwidth issues are not there. So it is 10. So shall we start or wait for a couple of minutes more?
I think we can wait for a few minutes, 5 minutes at least.
Okay.
Yeah.
Good morning, everyone. We have created one YouTube live streaming link. So if you wish to share it with the other participants who are not officially registered for the school, they can share the link. It is given in the chat box. Thank you. Good morning, Sanjeev sir.
Good morning, Indra.
So all set to deliver the good lecture.
Yes, set, but I don't know. You have to tell whether it is good.
So looking forward to it.
Yeah.
Welcome to the school.
Thank you.
So shall we start, sir? Ambud sir?
Just let because see from Dr. Ashokan, we can just yeah. Ashokan can see.
Yeah. Uh, I think director has not joined yet. So should we wait or we can start, then he can join?
Okay.
Hmm? He's in another meeting. So. Should we start, Ambush? Ambush, will start now?
Good morning. I'm sorry I got
Good morning. Good morning.
slightly delayed.
Yeah. Also, okay. We'll start the program.
Sure. Yes.
Yeah, okay. Okay. Good morning to all. On behalf of the organizing committee, I welcome you all to the school on iron beams in material science, this IBMS 2020. I request Dr. Ambit Tripathi to give brief detail about the genesis of this iron beam school. I also request him to share this session. Ambush. Hello, Ambuj.
Yes, so
Yeah,
I'm audible now. I just
you are audible. Yes, yes.
yeah. Acha, Indra, you can maybe share the slide now because that program has so we can just remove that slide. So okay, so good morning everyone. So I'd like to welcome all of you in this uh, school. So, as Dr. Ashokan said, I would like to say a couple of things about this school, how we started, and general things about it, because we saw from the participants list there was a lot of new faces. So, some of the things will be repetition, but just for the sake of completeness, I will try to, in a few minutes, try to give this brief. As you know, this our main facility is this Inter-University Accelerator Center is the main ion beam facility, one of the for universities, and we have a very large user base. So people are coming from all parts of India, and we had been organizing conferences on and off in the beginning, and somewhere around 2005 to 10, this regular conferences started taking shape. We had one Indo-German this workshop in 2005 and Indo-French in 2009, where we got these experts from this Indo-German, of course, with German groups, and Indo-French with the French participants. And there was response was very good. Then we realized that most of the researchers in India are unable to, especially younger generation, to return their work in different conferences, etc. Because you are unable to get this uh, audience, because traveling and all this is not possible. So we thought making it regular. So the idea of this conference, this IBMAC series, this earlier we used to call TRIMAC Swift Heavy Ions in Materials Engineering and Characterization. So that was the initial name. We started this conference, and then we realized that a lot of, because we have users who are changing every year, so there is a lot of younger people who are new. So it will be a good idea to precede it by a school. So somewhere around 2010, we started counting from 2010. It is as a regular series. So first one we did was and the Swift Finance in Materials Engineering Characterization in 2010 at IUAC. So that was sort of continuing what we had started with as Indo-German as the Swift Finance in material science. And when we had this Indo-French, that focus was on nanostructuring with IMB, because this was one of the major areas which had developed. So then we started alternate years. So in 2011, we had this nanostructuring with ion beams. So on focus with nanostructuring ion beams. So these are the two conferences we have been doing regularly. So on even years 2010, 12, 14, 16, 18, it was the SHIMAC, or later on instead of Swift ions, we thought we will include low energy also. So we started calling it IBMAC, ion beams in materials engineering and characterization. And alternate years it was this nanostructuring with ion beams. So 2011, 13, 15, 17, 19. And then we started doing it this alternate years, even years it was at IUSC, and then this odd years, this nanostructuring will be outside Delhi. So the other one we had done in places like we did it in Allahabad, Agra, Jaipur, Indore, and Kalpakkam. And even yes, this was here. So 2020 was this was supposed to be our sixth, and it was supposed to be at IUSC. But as you know, this pandemic thing has started, and we had a doubt whether we'll be able to do it. So we once postponed it, and we had, if you look in our academic calendar, it was planned in October. So we decided to postpone it to see whether the situation improves. But gradually, as we realized that situation is going to remain like this for some time, so the idea was either to cancel it or to do it in online mode. And as we have seen, a lot of things are going on nowadays online, as they say, the new normal. So we finally decided to do with this. And I am very glad that in a short time, when after that we started, both the conference and the school has materialized very well, and we have a sort of a very elaborate lecture schedule for next 5 days. And if you will see the list of speakers, we have some very prominent teachers this who are very good in their specialized field. So this is one thing which I always say. This year we are doing an online mode, but whenever we do it on campus, we are very lucky that there's a group of people from this European and other places, Japan and US, who always have been ready to come here and interact with our younger people, and they always come on their own. So we always thank them for that. This year it is of course offline, but still when we there are different type of issues. There is issues of timing. There are different other logistic issues, but I'm very glad that all the people whom we contacted very readily accepted. So we have a very nice group of people from India and from abroad. We generally try to keep them sort of half the talks on this and half on that. So you'll see very interesting talks with uh, from experts in the field. With like today, you will hear Professor Marcel Tulemon. After the first one will be by this Dr. Sanjeev Srivastava from IIT Kharagpur. They will give out the basics, and then and every day we have these two talks. One mostly Indian in the morning session because the timing doesn't match with the European, and afternoon you will see there is some European talk. So tomorrow it will be Dr. Som and Rahul from India, and Dr. Hans Hofsas from Germany. So this way we will keep on. The program has already been sent to you. So I will again like to welcome you all and thank all the this organizing team who have been doing, Dr. Ashokan, Dr. Indra, and all the other group members. We have large material science group with 10 scientists and all the RAs and research scholars. So we have been get cooperation from all of them. And all the major research groups, whomever we have contacted, we always get very good response, whether it is in terms of giving talks or uh, asking their group members to join. So with this, I would like to stop here and request our director, uh, Professor A.C. Pandey, to say a few words. He can, if possible, I would, he is busy in other meetings, so I hope I'm thankful that he could find the time. And if possible, there is one major thing which is a lot of interest and worry to younger people about the new education policy, in which he is very actively involved in different capacities. So if you can also say a few things about that. So I will request after our director, Professor Avinash Pandey, to say a few words. Thank you.
Thank you, Dr. Tripathi, Dr. Sokan, for giving me opportunity to connect with the strength of this center. Why I call the strength of the center that despite all these problems, all these challenges, we could invite more than 90 participants into this new normal mode. And that sometimes motivates us to keep our facilities operational. And despite when we thought about organizing this, there were many such requests and also suggestions that why not we discontinue and organize next year. But after giving a thought, we thought that this is not a proper thing to discontinue or to forego it for some other occasion. We should have the new way of interacting with the students. So as you requested, and then you wanted to say something about the new normal and also the policy which is coming very soon and has been adopted. We are in the process of finalizing the roadmap, how it could be put in place. So I'll share my slides and show some of the things relating to just a minute. Are you able to see the slides? Hello?
Not till now. So it's
Okay.
yes, sir. It's coming now,
Uh-huh.
and we have just reached 100. So
Okay. So century is there. But I'm not able to see my slides.
it might be in a different window on your screen.
Just a minute. I'll if I share my screen, I get the same window by which I could see all of you. So I should change the.
Sir, your whole screen is getting shared instead of the window. So
No, but what are the ways by which I can?
So, sir, from screen you can go to PowerPoint. Sir, on your screen, if you go to PowerPoint, that is open. I can see in the bottom. So there you can open your PowerPoint.
Okay.
Yeah. Now we can see it.
Okay.
slide is visible here. So
Okay. Now you can see. Okay?
Yes. Yes.
So with this prelude, that see, there was a challenge before the humankind, and we started experiencing several kind of problems. What we have to learn, how the experiences of our life. Because of that, we say that the best experimental lab is your own life. So how to handle such kind of situations? It is like looking at our lifestyle, and now you could have seen some of the things which has been advised to make ourselves survive, that we have to follow certain norms, and we have started following, including putting mask, making a sort of social distancing. Social distancing itself is a term which generally it's a contradiction. You are social and also you are making a distance. So, but despite the fact, we have to look at these issues. For us, when we are having this school, so it is not only sharing our ideas, our work which we have done in the last period, but also we are enabling our students. So the most of the students are from PhD, and also they are pursuing their career in sciences. So for us, the challenge for faculty is to how to become effective under this normal, to make our teaching and also learning relevant, so that you can understand, you can get connected, and also you keep continuing your interest in this area. When we talk about this student-centered learning, in simple lecturing, the issue is something different. But what we have to do, we have to find ways by which we can substitute active learning projects and experiences for lectures. So we have to get involved if we are following the norms of new normal, and we are also learning something, trying to learn without going to the laboratory. So it is not that the student-centric learning does not require good amount of material which is going to be covered by many of the speakers about which Dr. Tripathi has already explained, that many people from outside country, they're also entering and also joining hands with this particular school. We have to assign open-ended questions and problems, use simulations, role-playing, and the best part of this particular learning is that you can have your own self-spaced, or you can have your own virtual cooperative team to learn. If suppose something is not understandable by this mode, you can yourself form a group and interact with your group virtually and make a sort of self-paced learning issue. In conventional lecturing, what we have observed, that it is very impossible for a student to absorb everything which is given in a lecture. Very short memory is there. Only 20% of what I teach in a class is retained. Rest of the thing just goes. The second thing is that we need every student to learn, not just a few in a class where the heterogeneity is there. Generally, it is effective approach because all the students are actually confined into classroom, teacher is present, and you are forced to think actively and learn during that lecturing process. Your expectation is something different. You need something very kind of solid knowledge base and also real world applications, which is otherwise not possible if you don't go to the laboratories in a conventional form. You need that I should be very cogent and also have my thoughts organized in such a manner that you can understand clearly. You should be stimulated, you should be made active, you should be also participating in many of such events. Earlier, when you used to have this school, we tried to keep all these components into our schools, but this time I'm trying to make you aware that you have to make this opportunity in such a manner that you can learn a lot and you can avoid also such problems which are there because of this new normal. You want to know how does this activity reading connect to your future career? Because of that, Dr. Tripathi said that I should also speak about something relating to the new education policy. Want faculty to be enthusiastic, helpful, and engaged. We are, but you can always think that the faculty should be more enthusiastic. And what we expect from this, that we are service providing organization in some sense. So we have to think in that terms also. Face-to-face contact should be there, but now we have to accept these boundary. And because of that, we also have some kind of challenges. First challenge is keeping up with our field, by which we can let you know more and more, dealing with the students with varied backgrounds and skill levels, because in our this conference you might come to know that people have different background, despite the fact that we have focused the theme, we have a focused theme, even though our backgrounds are sometimes different, but we have to keep up everything intact, also in view of the time constraint. I'm talking about this because if you go for the competencies which we are going to develop in a student, earlier we were focusing only on a few things, like we used to remember some of the conceptual things which were actually to be understood. Then if you can apply some of the things, I used to consider that now you have mastered the subject. It is not only that. The new education policy is a significant departure from the earlier method of teaching learning process. It is now focusing on the higher level of competencies, that my student should have the capability of analyzing, have the capability of evaluating, and also have the capability of creating. It is not only limited to copying something and simply memorizing and by way of rote learning, reproducing the same thing without any input from his or her side. So we are moving towards higher level of competencies in which we are going to look at the assessment process also. I use this slide when I had to interact with the people who are in teaching learning process, you can also appreciate, this is a simple curve in which you could see that those who are good at understanding, those who have learned something by understanding, the probability of failing the examination is 0. Most of the people, if whatever the difficulty level is there, if you have understood, you'll definitely attempt the question and you can answer most of the things so that you can get passing marks. If you don't understand, you will definitely fail. It is not, but on the other side, if you see, good at understanding, you will pass examination, there is no doubt. Why I am worried about this? Poor understanding, even though you pass the examination. So I'm not, I can say I'm moderate in saying this 50%. If you take all the streams in the country, all the types of managements which are there in the country who offer higher education, this 50% is very modest. If I say that it is more, I'm not exaggerating. Why we have to worry about this? That traditional assessment has to go. While we are interacting in this school, we should always be mindful that anytime anybody can ask question which has been just taught to you, just share with you. So your active learning, your active involvement in all such talks is required. You don't consider as if I am recording this lecture, I am having the PPT with me, and I will use when I'll go home, or after 2 days I will brush up and then I will try to understand something. This is not the proper way of understanding or assessing the capability of a student. So whatever problem you have during the class, you can note it down. You can have your own virtual group by which, by sharing the problem among that group, invigorate those students also, those classmates also, to try to attempt those problems. And I'm firm believer that most of the learning takes outside the classroom. Inside the classroom, you are at the receiving end. You only receive what you actually, you are being given, what you are being served. So when you go outside, then you start connecting things and you start appreciating what was being talked and how it is connected to many of the other things which was actually not brought into the lecture. So using this new normal, when the school is being conducted in this way, you have to get maximum out of it, and you have to rethink, you have to actually format yourself in a different fashion. When I say why we call that good university teach, great university transform, this new normal has forced us to transform you. We are trying to become great because we are not only going to teach you, we are going to involve you. And while involving you, you will definitely come to know that you have started learning many of the things and you can now speak on your own. So you will not only become some kind of graduate or some kind of knowledgeable person after this school, but I expect that you could also become leader in some area where you wish to go. So keeping this all issues, the new education policy has focused in a different fashion. Coming to this, our school, you know, I have to always emphasize that accelerators are the tools which have been used in many decades. And we can also claim that 24 Nobel Prizes were given in the last 70 years just because pursuing physics or some other area using accelerators. This is what I can, you will miss this time. You will not visit the facilities which are spread over different beam halls. You have only focused way of looking the things. So you might have planned to visit material science beam line either in beam hall 1, beam hall 2, but we miss that our users are not with us. And these facilities are actually missing all of our users these days. Although we have started inviting users in batches so that they can follow the protocol, the new normal, and accordingly they can work without getting infected. So this we have started, but not the way, the full swing which we had in past when we had a lot of users in the campus. So we actually, if I say I'm really missing all of you by not having you in the campus. I'm talking about this restructuring which is going to take place. And by the time you will complete your PhD degree, you will come to know that all different kind of nomenclatures, that this is a university, that is deemed to be university, that is affiliating university, that is affiliating technical university, it is unitary university, that will all go. In past decade, we also developed the concept of mono university, that if law college is there and it's doing well, it becomes law university. Likewise, it is emphasized that the teaching is not compartmentalized, should not be. The systematic body knowledge should not be fragmented the way it is these days. Once we board a train means a stream, you are actually completely disconnected with the other domain. For example, if I opt for physics, mathematics, then I cannot know much about biology or other disciplines, liberal art, fine arts. This is not in the interest of the holistic development of a student. So this policy does take care that you can take credits from other disciplines, and it will be like making you a full knowledgeable person, not a specialist in the sense that you are very sort of narrow area you have pursued and you don't know much about other disciplines. So what we will try now, the problem is that if suppose every institution is going to get rechristened as university, the challenges are there. And the challenges are relating to their accreditation, assessment, and we have found some way by which we will classify the students, the number of students, number of faculty, and also the gradings which are there. And then accordingly, we'll go for graded autonomy to the institutions in coming days. And by 2040, it is planned that all the higher education institutions will become multidisciplinary institution. I'm emphasizing that it will not be limited to one commerce college or arts college or science college, but it will be a multidisciplinary institution and have students enrollments in thousands, not a small college having 100 students, 200 students. So overall higher education sector will be integrated into one higher education system, including professional and vocational education as well. So this is a significant departure. And accordingly, we have to gear ourselves, because there will be three types of institutions, universities. One will be research university. The second will be only teaching university. And the third will be autonomous colleges. Obviously, the service conditions and also the qualifications which are desired for becoming faculty in these three different types of institutions will be different. And if you wish to pursue your career in a research university, accordingly, you have to plan, and accordingly you have to take all those measures which shall be required in coming days. I talked about this more holistic education. The curriculum design is going to be like consolidating all the components. It should not be limited only to one discipline, which I emphasized. And again, if you remember the slide which I talked about, the outcome-based, the understanding, emphasis is on understanding. Emphasis is not that how much knowledge you have. So that will be the framework of LOCF, learning outcome-based framework. Your assessment shall also be a kind of summative assessment. It will not be a formative assessment. It will not be a summative assessment. Summative assessment means you study for 1 year and then you are tested. You study for 1 semester and then you are tested. It should be continual assessment. Even in your class, when you take a class, you complete one topic, you are assessed, and that marks goes to your main mark sheet. Likewise, STEM, this science, technology, engineering, mathematics, it should also become comprehensive. And we are devising ways by which we can engage many course options for a student, because the problem of real nature does not, you can say that it does not lie on one discipline. I cannot claim that I know physics and I can solve the real problems. So I'll come to that at a later point of time. Because of that, the holistic education is required, and to keep our faculty trained, to keep our faculty ready to take such kind of challenges, we have thought of having several such faculty development programs. And again, it will not be limited that you have missed the bus because of some issue. Miss the bus means you entered into a stream of a course, a program, and because of some reason you had to leave in first year, second year, or third year. Whenever you will leave, you will get some credit, and at your leisure, you can again join the course, get all those credits completed, get the next degree if you wish. Earlier, what happened that if you have joined a 3-year degree course, and if suppose because of certain exigency you had to quit in second year, you will not get anything, neither first year's credit nor second year's credit. So the entire effort will go wasted, and if suppose you don't come back in a specified duration, entire your effort will be in vain. But this time we are proposing, policy has proposed that we should have a credit bank in which all the earnings are stored, and whenever you want, you can use those earnings credit to get your value addition in terms of degree, certificate, diploma, whatever. Optimum learning environment is important, and support for students is already thought. So there will be a vibrant campus life. Assessment system is going to get remodified. There will be a differential learning where socially economic disadvantage, background, they will be handled separately. Slow learners, gifted students. Sometimes I know everything and I have to sit in the class because I am forced. If I don't take that class, my attendance will be short. That class may be not of much of use, despite the fact that I have to sit there. So for gifted students, how we can expand, how we can offer them challenge, that is also being planned. Curriculum should be relevant, and because of that, this affiliating system is being curbed, because in affiliating you have to follow the university norms. You cannot modify the syllabi on your own. And if you are progressive, if you need that this kind of thing is to be taught, definitely will be allowed. And this is what we have planned for our faculty. The regulations are being revisited. The norms are being changed for different types of universities, like research universities, teaching universities, and autonomous colleges. We will incorporate these regulations in statutes of respective institutions state-wise, and then we will have a concerted effort of filling those positions. A lot of opportunities are going to come in coming years. So you have to concentrate on your studies and get the degree as soon as you can. Many of the positions are lying vacant across the country in central universities, in other universities. So it is not that there is no opportunity in the country. Country has started these postdoctoral fellowships, which earlier we had to go to outside India and then pursue and then look opportunity at our own place. Here in our country, we have got ample opportunities in terms of variety of such PDFs. And we'll keep our trainers trained so that they'll be empowered one, and they will always be motivated, energized, and they'll be capable faculty in coming days. Coming to the last part, why we should think that what should be pursued. Sometimes we can classify it that what are the ethical issues in scientific research. The two main questions are how science should be conducted, and the second question is what science should be conducted. So you might be baffled to know that in physics we generally focus more on why, but here how and what other interrogatory marks are being also used. So to make it more clear, these how science should be conducted and what science should be conducted both have potential implications for sustainable development. Why I refer this point? quite a few times that the scientific revolution has outpaced the societal revolution in last 300 years, and because of that, the development in science is we can say that it insular, is monolithic, and now we are challenged by many such problems which actually endanger you, and pandemic is one such situation, and also the climate change relating to other issues. They are other byproducts of this kind of insular growth of sciences keeping behind the societal revolutions. So if you talk about how science should be conducted, these are the two misconducts which we should always be mindful. It is not that sometimes we come to know some kind of cartoons that this is online sort of teaching. Online teaching means you don't know much about, but you know how to do it, and because of that you land into some kind of trouble. So I'm reminding you that you have to be mindful that we should not conduct any experiment negligently. Negligence means we should always follow the process, the metrology issues, and if you remember in your earlier classes, you were taught what is measurement, what is the precision of measurement, what are the errors which may come into picture, and how we calculate those errors, whether your results are reliable, consistent or not. So negligence is one aspect of how we should conduct the science. And the second important thing is deliberate dishonesty. It should be like generally what happens that I have performed the experiment, somebody comes and then copies the table, does this calculation and get the things done. So that is deliberate dishonesty. You have to generate your own data. Whatever data which you get, it should be reproducible. It is not that I'm going to rely on some data or some curve is not fitting, and because of that my graph is not looking good, and then I can manipulate some data points, and then so these are some of things which generally it is not taught at early level. But when you pursue your PhD, you should always be mindful that how science should be conducted. Two important things. You should not be negligent towards taking measurements, and sometimes we report that, oh, we have seen this magnetic property in this, and which is generally not explainable. So you should look at what processes, what route you followed, and why you are getting this, which is otherwise not can be explained with the help of theory. Unless otherwise you are satisfied, without being negligent, you should not claim that this is my data or this data is proper. Deliberate dishonesty comes under different sort of this thing. So how science should be conducted, I give this example. Negligence should not be there. That means there must not be any kind of deviation from methodological norms, and deviation from moral norms should also not be there. So these are the two broad categories and this is only two broad categories which if you keep in your mind, you will always be happy with your results, and you will be in the quest of truth, and you will definitely be recognized worldwide. So negligence sometimes is reputable error. Suppose you followed some other method by which you got some result. So that are error because you did not deliberately injected something. We call it reputable errors, because if you did some experiment today and you found that at a later point of time you are getting something different, and you noticed what actually led to those deviations, you can again contradict your data that whatever I published last time had these kind of issues, and because of that the results were something different. Now I am claiming that because of these modifications, because of this new methodological norm, I'm getting this. So that is reputable. But if you deviate from moral norms, it will be difficult to defend yourself. And sometimes it is interchangeably, because people may not understand that it is deliberate or it is negligence. And if you don't mind these issues, definitely you will invite trouble for yourself. So coming to the list, the methodology part, what methodology? Characterization, you should have a hypothesis, prediction, logical deduction from hypothesis. You perform the experiment, test of all the above, characterization as well as hypothetical explanation as well as logical deduction. Then evaluate and iterate it. It is not that in one go you get satisfied that now, okay, I have done this much of work and now I can publish. So peer review is also a process by which we get inputs from our learned reviewers. They sometimes tell something which is generally ignored, or we can do it again and again. Unless otherwise we are confident that we are getting the results reproducible, we should not take the results as the results. So this is how science should be conducted. And now I can refer these things from a perspective of pedagogy, universalism, communalism, disinterestedness, organized skepticism. What universalism means? It requires that science be independent of race, color, creed, and that it should be essentially international. It is not that I have done experiment in Africa or in Australia or in India, the results are different. The results are all universal. The other terminology requires that scientific knowledge should be public knowledge. It should, if you have found something, it should go to the society so that society is benefited. The results of research should be published. Sometimes we generate a lot of data, we do a lot of work, but we refrain from publishing. We do not take that much of importance of publishing that data. That is also not good, because you have done something, and if it is known, then there will be no need of reinventing the wheel. So that part should also be avoided. Disinterestedness, it requires that results of bona fide scientific research should not be manipulated to serve considerations such as personal profit, ideology, or expediency. In other words, why I am highlighting this? Because you might have come to know several such reports in which the reports are to help somebody or something. So that should always be, being a scientist, your pursuit should be always the quest should be for unraveling the mysteries by arriving at the truth. The organized skepticism it requires that a statement should not be accepted on the word of authority, that Mr. X, who is a scientist of great repute or is director or whatever, he has said that it should be accepted. The scientists should be free to question them, and any truth which comes from these statements, they should be based on comparison with the observed fact. So don't follow me blindly, don't follow somebody blindly that he says that because of that it is correct. So these are some of the things which we always, and when we talk about this, what science we should do, you see the problem here. There are many sustainable goals, United Nations sustainable goals, in which it is highlighted that there must not be hunger, there must not be, we should have free from diseases, the old age people should be given. Our effort should always be targeted to find solution for some of the problems which ameliorate the conditions of the people, humankind. And because of that, what science should be done, that actually takes you to that level. So you might have understood the Faraday's law or other by using your fingers, left hand, right hand, in which or motion of charged particle in magnetic field, in which you say that this is a thumb, it directs this direction. This is index finger, it directs in this direction. It symbolizes the direction of this one. And the rest of the three fingers, they're all mutually perpendicular. When I take this example in our teaching learning process, one direction is teaching, another direction is research, and the third direction is community engagement. They look as if they are interdependent. They are the three different dimensions. But if you look at it very carefully, you will find that unless otherwise you are engaged in research, your teaching will not improvise. Unless otherwise you are a good teacher, your research will always be affected. Unless otherwise you are engaged in community for some services, you will not get an idea that what are the issues that we need to explore further. So your research gets benefited from community engagement. When your research gets benefited, you get a new way of explaining things, your teaching improves. So these are three mutually dependent, interdependent processes, and we should not think that, no, I'm only in teaching laboratory university or in research university, so I should not teach or I should not research or I should not engage into other community related issues. So that leads to the issues which we are actually plagued these days. Wherever you go, you'll find the water bodies in your vicinity. They are, and I call it because of the disjointness in scientific development and societal evolution. Those people who are using the benefit of the scientific revolution, they don't appreciate that this is going to create havoc, and that has made your life unsustainable over this earth. So overconsumption is one such cause of unsustainability, and unmindful consumption of many of the things is again the source for unsustainability. Thankfully, these days, the Delhi is not experiencing the gas chamber. Last time we had a tough time, and you are sitting at your own place, so you might not have suffered if you were to visit Delhi. But this is a common scenario in many of the industrial institute, and not only industrial. In Delhi, we get the stubble burning from other states, and the respiratory trouble and other things are there. This relates to our habitat. But what about other things? That is because of our unmindful development, they are becoming extinct. And every day, some of the species are being lost. They are becoming extinct. So that is another issue. I will sum up my talk. Whenever we pursue anything, always only thing should be there in our mind, and that is excellence. Excellence in research with global and social impact, excellence in outcome-based education for globally competent graduates, excellence in professional services and social engagement, excellence in management for sustainable organization. These are some of the things which have been the driving force for new education policy. And this is not only limited to new education policy, this should also be our traits, our character traits, which should get embedded into our psyche, and we should always strive to imbibe all those characters so that we can rejuvenate the science learning in this pandemic era. Holistic nature of knowledge, universal science and technology literacy, reinventing science education, scientific temper for the world, sustainability science for every citizen, a borderless view of science. So this is what makes you to be compelled to think that why I am not scientific, or why a person who has not studied science is not appreciating the value of science. So this is what all about what I wanted to share with you. And this has nothing to do with the ion beam thing. And the only thing I showed the beam hall, which is actually missing you to invite you whenever you find time, whenever the situation permits. You will always be welcomed by IUSC, our scientists, myself, and I'm looking for that day that everything becomes normal and you are there with us. Thank you very much.
So we'd like to thank Professor Pandey for giving a very exhaustive view in a short time of the three very important issues which the young researchers, the target audience in this group is going to be the things which are going to affect them very seriously and which are very important. The new education policy, how it is going to be, the ethics in research, and of course the sustainability. All three we have to worry about and keep a balance. So I will thank Professor Pandey again, and I think we can start. Ashokan, we can start with the technical session, or do we need to have break, or we can just start?
I think we can start.
Okay, so we will start with the lectures. First, of course, we have kept for the basics of ion matter interaction. This is where you start when you're talking about ion beams. So we had requested Dr. Sanjeev Srivastava from IIT Kharagpur. I will just give a brief introduction. We are very happy to have him here, and he is one of our research scholars. He did PhD from Material Science Group on the synthesis of compounds and nanophasors by Swift Heavy Enhance in 2002. After that, he did a postdoc in Max Planck, and then he came back, joined TIFR for a short time, and before he finally joined IIT Kharagpur in 2007, and then from 2013 onwards, he got associate professor, and uh, he is, as you will see, he will talk about the basics and start from the beginning. And as the target is among the young researchers, so a lot of you are new. So he will go in that pace so that you can catch it up. There will be a break in between, so he will be completing it in two parts, and there will be break in between 10 minutes or so, so that Sanjeev can have it whenever he feels it like. Sanjeev, you're there? I saw him, but
Yes, yes.
okay. So yeah, so now he has turned on his camera, so now I can see. So
Welcome, Sanjeev. I'm sorry I took your time. I did not notice that your talk is scheduled at 10:30. So I
no, sir,
okay.
No, sir, no problem. Thank you very much. It was a very, very nice talk and
Thank you.
very informative, presented in a very, very systematic manner. Very informative.
actually we had 1.5 hours, including the break and the lunch time. So we will adjust it. We are glad you could cover all that, because initially we had not planned it, but then we thought if you on this the new education policy and those things can be covered, it will be of a lot of interest to researchers. So we have flexibility in timing, so we will adjust it, no problem. So Sanjeev is up to you now.
So I will try to share the slide.
By the time Sanjeev sir is loading his slide, I would like to request the participants to keep the questions till the end. You can write them in the chat box so that he can deliver his talks in a convenient way. So all the best with the learning.
Is it visible?
Yes, sir.
Okay. Thank you very much, Dr. Tripathi, for the kind introduction. And I would also like to thank the organizers of the school, especially Dr. Ashokan, for inviting me to give this set of two lectures. The title is single, only one, Basics of Ion Matter Interaction. First, I would like to finish the acknowledgements. I had a lot of discussions with Professor Suleiman for preparing this talk, and I will be using a number of slides given by him. So the first acknowledgements go to him. Then I would like to acknowledge my supervisor, Professor D.K. Avasthi, the whole IUAC, the whole IUAC as such, Professor S.T. Kastanian from the erstwhile Max Planck Institute for Metals Research in Stuttgart, Germany, Dr. Paramita Patra, who was my student here, and now she is at IPR Ahmedabad. In fact, I would also like to acknowledge our central library, through which I could get all the relevant literature and authors of various literature, books, articles available on internet. The outline of the talk will be, I will start with a slide on what energetic ions can do while interacting with the material. Then there will be a first part, which will be essentially the basics of ion matter interaction, in which I will cover an analytical approach to formulate nuclear stopping power. a semi-analytical formulation of electronic stopping, finer corrections which are proposed for these theories about ion ranges and range straggling. Let me try to get a pointer. That will be better to have safe. So then part 2 will have some illustrative applications of ion matter interaction, and I will focus more on Swift heavy ion matter interaction. There I will talk about tracks, sensitivity, Coulomb and thermal spike models, velocity effect, Swift heavy ion mixing, and testing. So this is a list of all those processes which can happen when an ion interacts with matter. This is a picture taken from a source, and I am not going into the details of what all these processes are. I will just read the names. You can find out the meanings of all this from other sources. So the processes which take place, they are electron pickup, desorption, secondary electron emission, sputtering, shock wave generation, ionization, generation of delta electrons, Bremsstrahl and Cherenkov radiation, bond breaking, characteristic X-rays, elastic backscattering, scintillation or luminescence, heating, Coulomb explosion, nuclear reactions, elastic recoil, collision cascade, displacement, phonons, and implantation. Just a minute. Sorry. So this is a list, and while an ion interacts with matter, any one or more of these may happen inside the material. Now, studying each of these concepts is a big task that is not possible. But good thing about all these processes is that they all are deduced from two basic statistically independent processes of energy transfer to electrons and to nuclei. And these two components are energy transfer to nuclei. In fact, not to the nucleus, not inside the nucleus, but to the positively charged atom core, which is called nucleus in ion beam community. And these are generated from elastic collisions of the ion with this positively charged atom core. The second is energy transfer to electrons through inelastic collision. With this introduction, I will come to the basics. Before I describe the things, the theoretical things, I would like to give you some references. These references, 4 references, they give a comprehensive account on the theory of interaction of ion with matter. And you will get answer to all the questions for derivations of the results, for theory, for the concepts, everything you will get in all these references, and I have used these references for preparing my talk. Here, my strategy would not be to discuss all what is written on this book, in this books or references. I will try to present a minimalistic, easily comprehensible essence of the theories which are there for ion matter interaction. So when it is interaction of ion with matter, which is composed of atoms, the first impression which comes to mind is the elastic collision. So this is a classic picture of two-body elastic collision. So you have a projectile or an ion with mass m1 and velocity v0, which hits an atom in the material, which has mass m2 and is initially at rest at an impact parameter b. After scattering, this projectile goes in at an angle theta, at an scattering angle theta from the initial direction with velocity v1, and at the same time the atom is recoiled in another direction at an angle phi from the initial direction with a velocity v2. At any instant, the distance between the projectile and the atom to which it is colliding, this distance can be defined as the distance r, and you will have a distance of closest approach. This is r min, which is given by this. So this is a comprehensive or the concise, whatever you say, this is a picture of elastic collision. But this is not the only story. You have the elastic collisions. They will be dominant in the cases when the velocity of the ions is much less than something known as orbital velocity of k shell electrons or the Bohr velocity of the electron. So if the velocity of the ion is very, very low, then while interacting, it will have enough time to have Coulomb interaction with the nucleus of the atom, and there will be elastic collision because of the Coulomb interaction. While the orbital electrons in the atom, they are much, much faster than the ion which is coming inside. So there will be very, very weak interaction between the projectile ion and the electrons. So the electrons will not get any energy as such. So these are dominant elastic collisions. But if you have ion velocities which are equivalent to the Bohr velocity, equivalent to the velocities of the electrons in the atoms, then this particular ion, it stays for a long time with an electron in the atom, and it gives a lot of energy to that particular electron. While since it is very fast, it will not have enough time for Coulomb interaction between this between itself and the atom, and there will be no elastic collision. So these are two kind of extremes, and the details can be found in the chapter 1 of one of the books which I have referred. Now, in fact, you will have both the collisions together. Elastic collisions in which the projectile will scatter at so projectile with an energy E0 will scatter with an energy E scatter, and because of the inelastic collision, the electrons of the atom, they will go to higher excited state, so it will be excited, and there will be excitation energy going into the
Sanjeev
electron
sir,
cloud.
your audio is not audible.
Not audible. Okay. So let me try one thing.
Sanjeev, your voice is okay. Now it is not there.
So it's fine, sir. Please continue.
Please unmute. Unmute. Sanjeev, unmute your mic.
Hello.
Yeah, it's fine now. Yeah, continue.
It's fine now. Okay.
Yes, yes.
So is it okay now?
Yes, it's fine.
Okay. So you have a combination of two kinds of energy transfer. One is because of excitation and the other one is because of the elastic collisions. And the total energy which is lost by the ion will be a sum of these two processes, E excitation plus E recoil. Okay, E recoil will be there. And excitation and this E excitation plus E recoil is the energy lost, which you also say conventionally E electronic and E nuclear. And if the ion goes into a material medium, it has to cross a lot number of electrons, a lot number of atoms. Then you talk about the loss in energy per unit length, dE by dx, which will have two components, elastic energy loss component and inelastic and the elastic energy loss component, which you call SE plus. So these two things, elastic and inelastic, they are together. Now, what is the theory behind the nuclear energy loss or the elastic collision? Once again, we come to the same picture which we have seen. I just remind you. And I put the same picture here so that you can have ready reference. Now, this collision will depend on the potential, the electrostatic potential between the projectile and the atom. This is VR. Now, this potential will it be equal to Z1 Z2 E square by R as it is Coulomb. This is the electrostatic formula. Perhaps no, because it is not their nucleus here. It is not their nucleus here. So you cannot take charges Z1 and Z2 as such. There will be some modification in the charges, and so there will be some modification in the potential. There are two factors which modify the potential. One is the effective ion charge. The first thing is that the ion may not have, while it is moving, may not have all the electrons. So since it is ion, it will not have Z1 number of electrons. It will have less number of electrons. That is the effective ion charge. And second is the screening of nuclear charge. So consider this picture where this is the atom inside the material and the projectile is going at this particular distance from the nucleus. Then all the electrons outside this distance, they will not have any effect on the determination of charge Z2. But those who are below this, they will shield the nuclear positive charge and they will reduce the effective charge from Z2 to some other value. And this depends on how much distance is how much distance is the ion from the nucleus of the atom where it is colliding. So this potential will be modified by a multiplication factor chi, which will depend on the distance r between these two things, divided by some a constant, which is screening parameter, and usually this is an exponential function. So there is an exponential decay of this potential, and because of the exponential decay of the potential, the collisions, they will be very short range. And so when suppose the ion is here, it will have collision with one of the atoms, but for other atoms, the electrostatic potential will decay very fast, so there will be no interaction. So basically, it will be only a two-body collision, which will be of significance. Once you have decided that it is a two-body collision, I have the same picture once again. So we work out the conventional theory of scattering by starting with conservation of energy. This is the formula for conservation of energy. Then we consider the conservation of momentum, two kinds, longitudinal momentum and lateral momentum. So I will not read the formulas. These are very standard formulas. So you start with this, and then you convert this problem into the center of mass coordinate problem. So now your projectile of mass m1 is moving in the center of mass coordinate with a velocity v0 minus vc, while the one which was at rest, the atom, it is coming towards the ion at a velocity vc, and there is scattering, and you will have scattering angle which is capital theta. the recoil angle, which is capital phi. Then you have reduced mass mc equal to m1 m2 by m1 plus m2. This system velocity vc is determined by m1 by m1 plus m2 v0. The center of mass kinetic energy is half mc v0 square, and then you can have a conversion between theta, small theta, and capital theta given by this relation. And if you work it out, then the energy transferred to the target T, which is equal to half m2 v2 square, this will come as 4 m1 m2 by m1 plus m2 whole square E0 sine square capital theta by 2. And this energy which is transferred to the target is the energy lost by the projectile. So from here, the energy lost can be calculated. The next step, once again, the conventional elastic collision problem, we need to use the Lagrangian mechanics in center of mass polar coordinates, where the energy EC, this is the center of mass energy, which was defined earlier. This is written as half mc r dot square plus r square theta dot square, where dot represents the derivatives with respect to time, which is equal to half mc v3 square. Then the angular momentum is defined by mc r square theta dot. And if you work it out, I'm not going into the details of all the derivations, then r dot, which is equal to dr by dt, is given by vc 1 minus vr by ec minus p square by r square raised to the power half. And from here, by setting this dr by dt equal to 0, you can find out what will be the minimum, so distance of closest approach. So you can find out what is the distance of closest approach from here itself. And you will get theta dot, which is the theta by dt. This is equal to vcp by r square. Now you combine these two, d theta by dt and the dr by dt and d theta by dt, get d theta by dr, which is d theta by dt times dt by dr. And from these two, it will be b by r square 1 minus, so this expression. And if you integrate it, you can find the value of capital theta as a function of r, which will be an integration from minus infinity to infinity, this factor, which will be equal to 2 times r minimum, which you have determined from here, to infinity v dr by this factor. This is general orbit equation. Once you have determined this general orbit equation, you know what is this theta as a function of r, means you know what is exactly the orbit of the electron. This will tell you what is the orbit of the electron. And the orbit of the electrons, the ions, sorry, orbit of the ions, and the orbit of the ions is determined by the impact parameter B. You can see, of course, it will be determined by the potential, the other things, but it will be determined also by the impact parameter B. So a particular theta will correspond to a particular impact parameter. Now, if you are looking for the projectiles coming in a range from B to B plus or B minus dB, this distance